Section 1 of Familiar Letters on Chemistry. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by M.L. Cohen, Cleveland, Ohio, March 2007. Familiar Letters on Chemistry by Justice Liebig. Letter number 1. My dear Sir, the influence which the science of chemistry exercises upon human industry, agriculture, and commerce, upon physiology, medicine, and other sciences, is now so interesting a topic of conversation everywhere, that it may be no unacceptable present to you if I trace in a few familiar letters some of the relations it bears to these various sciences, and exhibit for you its actual effect upon the present social condition of mankind. In speaking of the present state of chemistry, its rise and progress, I shall need no apology if, as a preliminary step, I call your attention to the implements which the chemist employs, the means which are indispensable to his labors and to his success. These consist generally of materials furnished to us by nature, endowed with many most remarkable properties fitting them for our purposes. If one of them is a production of art, yet its adaptation to the use of mankind, the qualities which render it available to us, must be referred to the same source as those derived immediately from nature. Cork, platinum, glass, and caoutchouc are the substances to which I allude, and which minister so essentially to modern chemical investigations. Without them, indeed, we might have made some progress, but it would have been slow. We might have accomplished much, but it would have been far less than has been done with their aid. Some persons, by the employment of expensive substances, might have pursued the science, but incalculably fewer minds would have been engaged in its advancement. These materials have only been duly appreciated and fully adopted within a very recent period. In the time of Lavoisier, the rich alone could make chemical researches. The necessary apparatus could only be procured at a very great expense. And first, of glass. Everyone is familiar with most of the properties of this curious substance, its transparency, hardness, destitution of color, and stability under ordinary circumstances. To these obvious qualities we may add those which are specially adapted to the use of the chemist, namely, that it is unaffected by most acids or other fluids contained within it. At certain temperatures it becomes more ductile and plastic than wax, and may be made to assume in our hands, before the flame of a common lamp, the form of every vessel we need to contain our materials, and of every apparatus required to pursue our experiments. Then how admirable and valuable are the properties of cork! How little do men reflect upon the inestimable worth of so common a substance! How few rightly esteem the importance of it to the progress of science and the moral advancement of mankind! There is no production of nature or art equally adapted to the purposes to which the chemist applies it. Cork consists of a soft, highly elastic substance as a basis, having diffused throughout a matter with properties resembling wax, tallow, and resin, yet dissimilar to all of these, and termed suberin. This renders it perfectly impermeable to fluids, and, in a great measure, even to gases. It is thus the fittest material we possess for closing our bottles and retaining their contents. By its means, and with the aid of caoutchouc, we connect our vessels and tubes of glass, and construct the most complicated apparatus. We form joints and links of connection, adapt large apertures to small, and thus dispense altogether with the aid of the brass founder and the mechanist. Thus the implements of the chemist are cheaply and easily procured, immediately adapted to any purpose, and readily repaired or altered. Again, in investigating the composition of solid bodies, of minerals, we are under the necessity of bringing them into a liquid state, either by solution or fusion. Now vessels of glass, of porcelain, and of all non-metallic substances are destroyed by the means we employ for that purpose, are acted upon by many acids, by alkalis and the alkaline carbonates. crucibles of gold and silver would melt at high temperatures. But we have a combination of all the qualities we can desire in platinum. This metal was only first adapted to these uses about 50 years since. It is cheaper than gold, harder and more durable than silver, infusible at all temperatures of our furnaces, and is left intact by acids and alkaline carbonates. Platinum unites all the valuable properties of gold and of porcelain, resisting the action of heat and of almost all chemical agents. As no mineral analysis could be made perfectly without platinum vessels, had we not possessed this metal, the composition of minerals would have yet remained unknown. Without cork and caoutchouc, we should have required the costly aid of the mechanician at every step. Even without the latter of these adjuncts, our instruments would have been far more costly and fragile. Possessing all these gifts of nature, we economize incalculably our time, to us more precious than money. Such are our instruments. An equal improvement has been accomplished in our laboratory. This is no longer the damp, cold, fireproof vault of the metallurgist, nor the manufactory of the druggist, fitted up with stills and retorts. On the contrary, a light, warm, comfortable room, where beautifully constructed lamps supply the place of furnaces, and the pure and odorless flame of gas, or of spirits of wine, supersedes coal and other fuel, and gives us all the fire we need, where health is not invaded, nor the free exercise of thought impeded. There we pursue our inquiries, and interrogate nature to reveal her secrets. To these simple means must be added the balance, and then we possess everything which is required for the most extensive researches. The great distinction between the manner of proceeding in chemistry and natural philosophy is, that one weighs, the other measures. The natural philosopher has applied his measures to nature for many centuries, but only for 50 years have we attempted to advance our philosophy by weighing. For all great discoveries, chemists are indebted to the balance, that incomparable instrument which gives permanence to every observation, dispels all ambiguity, establishes truth, detects error, and guides us in the true path of inductive science. The balance, once adopted as a means of investigating nature, put an end to the school of Aristotle in physics. The explanation of natural phenomena by mere fanciful speculations gave place to a true natural philosophy. Fire, air, earth, and water could no longer be regarded as elements. 3 of them could henceforth be considered only as significative of the forms in which all matter exists. Everything with which we are conversant upon the surface of the earth is solid, liquid, or aeriform. But the notion of the elementary nature of air, earth, and water, so universally held, was now discovered to belong to the errors of the past. Fire was found to be but the visible and otherwise perceptible indication of changes proceeding within the so-called elements. Lavoisier investigated the composition of the atmosphere and of water, and studied the many wonderful offices performed by an element common to both in the scheme of nature, namely oxygen, and he discovered many of the properties of this elementary gas. After his time, the principal problem of chemical philosophers was to determine the composition of the solid matters composing the earth. To the 18 metals previously known were soon added 24 discovered to be constituents of minerals. The great mass of the earth was shown to be composed of metals in combination with oxygen, to which they are united in 1, 2, or more definite and unalterable proportions, forming compounds which are termed metallic oxides, and these, again, combined with oxides of other bodies, essentially different to metals, namely carbon and silicon. If to these we add certain compounds of sulfur with metals, in which the sulfur takes the place of oxygen and forms sulphurets, and one other body, common salt, which is composed of sodium and chlorine, we have every substance which exists in a solid form upon our globe in any very considerable mass. Other compounds, innumerably various, are found only in small scattered quantities. The chemist, however, did not remain satisfied with the separation of minerals into their component elements, that is their analysis.